From South Bend, Indiana, welcome to 3 Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
If you are trying to dial in a process and then you have to sit on your hands for a couple weeks while parts go out to get section polish mount before you get the data back to say what your next move is, that can be quite burdensome, right? And your machine's sitting idle and can be quite frustrating.
That was Jonathan Pegues. Jonathan helps teams push the science and application of advanced manufacturing forward with a career rooted in microstructural analysis, process optimization, and practical problem solving across refractory and reactive alloy systems. His unique ability to translate deep technical insights into real-world solutions, improving product performance, streamlining development cycles, and bridging the gap between R&D, manufacturing operations, and industry partners. He spent his career helping organizations understand how manufacturing decisions impact material behavior and long-term reliability. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast, where we can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, or general additive manufacturing data management support, reach out to the team through our website or via email at info@3degreescompany.com. All right, I'm excited for the conversation today. So, Jonathan, as we get into it, I think what I always like to start with is the foundation. So, where were you born? Where'd you grow up? Do you have any seminal moments that kind of you recall as getting you on the path towards where you are today?
Yeah. So I was born in Lubbock, Texas, actually, but I primarily grew up in the Jackson, Mississippi area. Kind of maybe a non-traditional path, particularly into additive. But what sparked my initial, exposure to additive was joining Nima Shamsay's PhD program back when he was at Mississippi State, actually. And I actually joined as just a student working in fatigue and not even doing additive. In fact, for a long time, I tried to stay out of it because of all the, the additional activities I thought it required, and thinking like, oh, it's a fad. It's going to spur up a lot of interest. It's going to die down at some point. But I moved over with him to Auburn University to help him start Incame, and so that at that point just had to get into it. And I would say that pivotal moment was really kind of looking at the process, structure, property relationships, and just getting kind of enamored into the metallurgy of additive manufacturing, right? Melting and solidification, and trying to understand how that ultimately impacts fatigue behavior. And then from there, I've carried it off into other activities like refractories and things like that. Just trying to learn to and better understand that process so that we can create better and better materials. So I would say that was really kind of the pathway into the career that I've had so far.
Did you always want to be an engineer?
No, I actually wanted to be a architect. and when I joined Mississippi State, that's what I initially joined into the architecture program. But that was back in 2009, right after the housing crisis, and so I just started looking for something that I thought was safe. So, and landed in engineering somehow, and fortunately, I was doing a lot of math at the time, so it wasn't a huge switch from art into the science world. So, I jumped into mechanical, thinking that was even the safer of the engineering choices, and I haven't looked back since.
And what did you think about, or what were your thoughts when you first saw 3D printing?
I thought it was cool. So my first exposure was to an Optimex system, a blown powder DD system, and I was like, "Oh, that's cool." And the resolution on those were quite low, and particularly at the time, right? It was old. Even at that time, I think it was like a 20-year-old system that had been donated to Mississippi State, and so I was like, "Oh, that's cool." You can create parts. It's not super attractive to me at the time, but when we got the first powder bed system, that's when I started saying, oh yeah, you can actually do some really neat stuff with this. And then over time, I grew to appreciate DED even more and more, and just understanding the places of the two different systems and what you could do with each of them. And yeah, so it's been a quite interesting journey, I would say.
And talk about, I mean, you mentioned NCAM, and we've had, as you mentioned, you had Neem on the show, but I mean, I think one of the unique things about additive, and we just had the ICAM show a couple of weeks ago, or last week, I guess, is this unique, I don't know how unique it is, but it seems unique for the industry of a very high collaboration between government, academia, and industry. So kind of from where you sat, like how tight were those kind of those collections? Were you doing a lot of independent, like, I wouldn't say research for the sake of research, but more directed research, solving kind of industry specific issues, or kind of what is that dynamic as you've seen evolve over the time you've been in additive?
Yeah, I would say early on, I would say I was probably a little more unique in our research group, in that I was kind of defining my research project. I was able to convince Nima to let me do something that I wanted to do, but in order to do that, since it wasn't funded, I had to do things on the side that were bringing in money, and so my specific dissertation topic was really kind of more the fundamental side of the process structure property relationships, but then trying to solve some of the challenges particularly in the fatigue and fracture space around surface roughness and how that was going to impact the overall lifing of parts that were fabricated. And so engaging with a lot of the Department of Defense folks and just understanding the materials of interest, and then trying to apply what I had learned all the way up to that time to those applications. And that's what I do think is quite fun about additive, is that it does bring in all these different actors, right, from the government and industry and academia, to try to marry all these things together. And beyond that, it also brings in your different subject matter expertise, right? It's to me, what I think is attractive is kind of bringing back the metallurgy sciences that seem to have been slowing down in the universities, and kind of propelling those forward, and bringing them in, and welding engineers, your structural folks, all getting together to try to solve some of these unique challenges that are associated with that rapid solidification process, at least in the melting technologies.
And so what would you say, what is your kind of focus today? Like where are you, maybe talk about kind of where are you in the organization, but more so also kind of what sorts of things are you doing on a day-to-day basis? What's your day like?
Yeah. So when I joined NCAM, about a year ago. And so one of my main goals was kind of spearheading some of the applied research that the center was interested in building up as a capability. I would say since I graduated and went into the national lab sector, and then into the industrial sector, I think one of the things I've recognized is a real challenge for adoption of these processes is the connecting those process structure property relationships, particularly in the process development side of things, right? If you are trying to dial in a process, and then you have to sit on your hands for a couple weeks while parts go out to get section polish mount before you get the data back to say what your next move is. That can be quite burdensome, right? And your machine's sitting idle, and can be quite frustrating. And so one of the things I wanted to instill here with the center was this kind of rapid pace that better aligns with the pace of additive manufacturing, particularly in the prototype stages of things. And so that's really what we've been doing for the most part of this past year, is trying to, because we already had all these capabilities internal to NCAM, right? We have the additive manufacturing platforms, we have the testing capabilities, we have the metallography lab, we have the in-depth characterization lab. But I would say they weren't, necessarily efficient in that process, right, to move things through. And so we've been really focusing on that over the past year. And part of that is, instilling a a standard or quality management system, right? And so we targeted, the AS9100 and the AMQ that's offered by ASTM to try to help us align all this, and then at the same time get our students and our other research faculty, kind of I guess familiar with that type of pace, right? To be able to print something and quickly turn it around and section and look and say, hey, how close are we? Do we need to move back and do other development builds? And then, increase those cycles, and then ultimately lead to, a rapid way of testing and getting some baseline data that we can offer. And so I would say we've been pretty successful at that over the past year. We've really been interfacing with a lot of powder manufacturers, and then also more defense type work, and bringing in and trying to, at least provide that type of information that's so valuable to them to be able to adopt the technology and move forward from a part standpoint, right?
Sure. Yeah. And what are there specific alloys, specific technologies that you mostly focus on, or that you've seen at least an interest from industry or some of the sponsors that are helping with the work?
Yeah, to the big ones, or at least for me, is in the refractory space. So your niobiums, or the common one, C103, but even novel alloy designs, particularly in the high entropy alloy space or even medium entropy alloy space, where the kind of the design freedom there is quite large, right? To try to solve some of the challenges that exist with those materials. So, for instance, say something like C103, right? That has a pretty high market volatility based on the hafnium that is alloyed into that material. And so one of the things we've been looking at recently is, are there pathways to eliminate that, but still get similar type performance from leveraging this more complex alloy design space with the medium to high entropy alloy space. And they bring their own challenges, right? They typically oxidize readily at very high temperatures, so they often can't be used to just by themselves. They need some kind of coating application to overcome those challenges. And so just thinking about those challenges and trying to apply kind of what we've at least apply our process tools to try to help solve those, right? And so I mentioned, the learnings that we had in DD and how I came to appreciate that. And to me, that's one of the big ones, right? Being able to do some in situ alloying and grade across large compositional ranges and consolidate. Normally what you would have is, several different metallurgical coupons that are each individual alloys. But now taking that and just consolidating that down into one coupon that you can then run through the process one time and get spatially different alloy compositions across the build height. So leveraging things like that to try to solve some of these large challenges that exist with applying some of these novel materials into the production space.
And I mean, with the kind of global economic scene, I imagine some of these materials may be impacted by whether it's tariffs, whether it's trade policy and things like that. How do you guys play a role in that? I mean, obviously you're not at production scale, right? So you're not bringing in tons and tons and tons of this material, but at the same time, you're probably in an advisory role for government or users to say, okay, hey, like you might want to keep an eye on this because of this key component here is on one of those lists, or is kind of one of those things to watch. Has that been cropping up over the last few months?
I don't know specifically about the some of the trade impacts, but I know we've had a lot of interest working with powder manufacturers that want to tweak their chemistry or come up with a new process or different type of powder, and trying to understand is this going to give me the performance that I'm after, to provide something to the community that is of interest. So. For the folks that attended ICAM this past week, our colleagues over at Amaero, Eric Bono, presented on some of the interesting work they're doing with adding nitrogen as a as an interstitial to improve the strength of grade 23 titanium, right? And so kind of targeting, the printability of grade 23, but achieving the strength properties of grade 5. And so, we were very happy to be a part of that research effort and see the success of that, ultimately leading to that presentation there. So I would say that's the big thing. Really we kind of get the triggers from the government themselves or the industry partners that come to us with challenges and say, hey, this is what we're looking to do to solve this problem, and then just really kind of connecting our expertise and in particular that process structure property chain that we have here under one roof, right? To be able to quickly give them that answer or start exploring and seeing what the bounds of that space is.
Yeah, one of the things with the podcast that I like to do is kind of get people's perspectives on how their career trajectory has gone. You mentioned that, I mean, you have the very strong academic background, spent a lot of time at the university, but you've also been in a national lab, you've been in industry. Maybe talk about kind of some of those experiences and kind of what you take from each of those in terms of how you think about kind of how you do your job today and how you think about kind of what your career looks like in the future.
Yeah, absolutely. It's interesting, right? You go and when I was a green-eared engineer coming out of Incame first, I thought I was going to go into the national lab and out into the world and solve all the problems in additive, and then you start getting these different perspectives, right? The needs at Sandia National Labs were much different than what we were seeing from the folks over here in Department of Defense or industry when I was here as a grad student, right? And having to adjust and say, well, okay, well, I think my expertise really is valuable here, but it seems that I need to pivot a little bit to try to provide some value, specifically where I'm at. And so, like the big thing at Sandia was seeing that really some of these wire-based capabilities were of high interest, right, and might really be the key to solving the challenges that they were facing. And then moving on, I went to Castheon, and I think that was very eye-opening as well. Just getting that industry's perspective, particularly from a contract manufacturing point, right? And how do you do this at production rate, right? While still trying to maintain all your quality controls and things like that, trying to navigate that space, I thought was very, I learned a ton there, and I think I brought a lot of that back with me when I rejoined Incame, to try to provide something that I thought, both from the national lab sector, from the contract manufacturing sector, from defense, would be of tremendous value to them to try to break down those barriers. And that's, again, really just trying to offer quick turnaround to some of the questions that they may be having, so they can link kind of that fundamental understanding back to the target application or something along those lines.
And now, I mean, put yourselves in, if you're a student kind of starting now, or if you, like you yourself are kind of at that early stage of kind of deciding what that fork in the road is for you. I mean, from your perspective, what's changed on the additive manufacturing side, even through NCAM as a vehicle, that, like, what are students doing today that you couldn't even imagine 5, 10, 15 years ago when you were kind of on that path?
Well, just seeing the technology as a whole kind of maturing, right? I think in the early days, the in situ or in process monitoring capabilities were quite limited, and trying to understand what value they provided, I think, was at that time was unclear. In fact, when you would talk to some of the providers or people that were offering that service, a lot of times they would tell you that they don't really know what the data means, right? And so I remember finding that interesting when we would communicate with folks that were trying to sell us systems and things. But now I think that value offering is much more clear, right? And the sensors have gotten much better, and people are kind of understanding now, okay, how do we apply this maybe to supplement something like X-ray CT or something along those lines, so we don't have to go through 100% CT process to ensure the quality of our parts. So I would say that's the big thing, and then also just the control of the systems themselves, right? Increasing and maturing, seeing things like coming like some of the smart fusion technologies, right? The feed forward loops that are monitoring thermal signatures and adjusting process in real time. I think that's very intriguing, and it's going to lead to some maybe not accelerated adoption, but accelerated understanding of how do we create consistent parts in a production environment and ensure that quality is there without having to do all this excessive post processing, hipping or things of that nature to kind of buy down that risk, right? Maybe just increasing the risk appetite across the board for the folks that are interested in adopting additive manufacturing.
I mean, you've mentioned kind of defense and some of the armament work, but do you see other industries kind of jumping on board as big time users or big time collaborators with what you guys are doing? Is there like kind of a progression that you've seen into like different industries?
Yeah, I would definitely say medical. As you see a ton of activity in medical. I think they're kind of demonstrating the ability to use additive manufacturing and in more critical applications. I would say the one that surprises me the most is construction, right? And I feel like that sector has really been ramping up. I also serve as the vice chair for the ASTM F4207, which is the subcommittee on applications. And so construction is one of those applications, right, that we have there. And yeah, just seeing just across the globe how much interest there is in the construction space and
that like concrete printing or thing like that sort of thing or something else?
Yeah, well, it includes that, but yeah, I mean, this was one of my big surprises. It's not just concrete printing, right? There, you've got people that are just building wall panels, right? And so they're doing it with traditional or I guess more conventional additive processes, and then assembling them and things like that. So yeah, just seeing how each of these different sectors is growing and kind of what the interests are and what what they see as the key challenges, because it's different across the different sectors, right? And being a fatigue person, right? When we first got into it, we understood that fatigue was going to be a big limiting factor in the aerospace kind of side of things. But as you engage with some of the oil and gas folks, right? They do have some concerns with fatigue, and but maybe not as high, and so they don't need as much of that upfront data to qualify machines as you would see from civil aviation or even defense. So yeah, again, going back to your point with it just brings all these different folks together. Me as a metals guy, I'm always intrigued to kind of see what maybe the polymers or the concrete or just other people are doing, what those other sectors are engaging with, and how they're solving other problems that maybe I'm not as familiar with.
And I mean, speaking from the university perspective, I know you do a lot of obviously contract research, collaboration with government, industry, and things like that. But on the student side, like how I know there's tons of talk today is like, hey, like, is it worth it to go to university? Like, what are some of the ROIs? Like, how are some of your students thinking about that in terms of kind of what they're doing after kind of getting the experience in the department, in the center, in the labs? Like, how is that working out for them? I know there's been a little bit of a slowdown in AM, but have you seen that kind of reverberate back through to on the student side, or is there still lots of opportunity out there?
Yeah, I think we've seen it across the board. We've had students that came back from industry to say, hey, I want to pivot a little bit and I want to get more into the R&D space. And so I think this, going back to school and working for a center like InCame really kind of provides me that opportunity to learn the research side of things, particularly when it comes to process development and things like that. We also see a ton of interest from the upcoming undergraduate students that are seeing the capabilities, and 3D printing as a whole is getting more and more commonplace, right? It's you can get a nice FDM printer, right, for a few $100 these days. So, yeah, I would say what's different from when I was a grad student is that the students are coming in kind of with a little better understanding of this layer wise type process, right? And so I think that one is kind of driving some of that interest, right? Particularly when they start saying, "Oh, I can do this with metal as well," and they just coming in with that interest, right? Because to succeed in grad school, you really got to have that drive, right? And kind of that connection of why am I doing this, and what's the benefit I'm going to get on the in the long run. And again, I think really just kind of mirroring back all these processes and understanding that it's not just printing, right? It's also the characterization and analysis of the print, and trying to really dig into the laser material interactions, and how that ultimately impacts the structure, the solidification structure, the microstructure. And so they come in, and I would say we see more interest of not just being a mechanical engineer, but also looking into the material science side of things, or even the statistical side. So a lot of our students now, I would say, when we used to be more of just the materials kind of background, trying to get the metallurgy side, but now we have a lot of students that are also really diving in to the statistics, right? To say, well, once we get something dialed in, right, part of the quality assurance, right, is having some baseline data, and particularly having it statistically driven, so that you capture that variability that's commonplace with the process itself. So yeah, I would say those are the big things, and I think getting them exposure to some of the, particularly the industry side of things. A lot of times that's the questions they have. Well, what does this look like from, if I don't want to be in academia, what does it look like from an industry perspective? And it's always helpful to have people like myself that have kind of seen from the national lab and contract manufacturing space to provide some of those answers to them, and see where they go. We've had students go, a lot of them go into the national lab sector. We've had a lot of them go into the space flight sector. Several of them go into standards organizations. So, I think Dr. Shumsey would tell you the same thing. It's very rewarding to see these students go somewhere and excel, particularly in the different sectors, right? Leveraging different skills to help try to solve these challenges that are associated with AM.
So thinking a little bit ahead, I mean, what are you excited about from either a trends perspective, work you guys are doing in the next 6 to 12 months? What's on your radar? What are you excited about?
Well, the thing that gets me up every morning is the alloy design, right? Trying to manipulate the chemistry, right, to achieve specific things, right? I think conventionally, or at least conventional alloys have just kind of been thrust into the AM space without, mostly because that's what was available, right? But as the community's grown and starting to realize there's better alloy combinations or chemistries that would align better with that rapid solidification process, right? And then just trying to apply that to solve just general material science challenges, right? Like how do things fail, and is there ways we can manipulate the process structure relationships to overcome those? So my dissertation was exactly along those lines, right? If we understand the AM process and the conventional process of austenitic stainless steels, right, this kind of gives us an opportunity to avoid those early fatigue crack initiation features. And in that case, it's really specific grain boundaries that drive crack initiation rather than defects. So as long as the defects are small, and you can avoid those specific grain boundary features, you can actually dial in your process to give you longer fatigue life. And so we were able to demonstrate that when And as I mentioned, when I left, in my early career, I thought, oh, I was going to solve all the problems in AM this way, and quickly realizing that was not going to solve everything. It's going to be material specific and getting better understanding of the defect microstructure interactions and how processing and post processing can adjust those things. So I would say that's the big thing. From my side, I would say some of the more interesting uh, uh, topics that are emerging from within the center are these equivalency based approaches, right? Trying to develop material models that are transferable across different AM platforms as a way to minimize the amount of testing campaigns that one would have to do to stand up machines, right? And so I think there's a lot of really cool work that's going on in that area. And then again, just providing some services to whoever may need it, right? To connect those process structure property relationships in a way that's really quick, and at least aligning with what people are doing, right? Because if it takes you 6 months to get an answer, right, the fast prototyping additive manufacturing is no longer fast prototyping, right? If you might create the part really quick, but if it takes you too long to characterize and understand its performance capabilities, then it tends to be a hindrance rather than an enabler of the technology.
And so one last question, more of a fun one. We've been kind of compiling a 3DegreesDiscussions podcast book club. And so is there a book, even we've broadened it to a podcast you like, or something that has kind of given you inspiration, food for thought over the last few years that you'd like to share with the audience, and kind of share some of the things that you took away from that?
Well, just a book in general, or does it need to be
anything you want? It's been all across the board.
Oh, okay. Oh, let's see.
We've had sci-fi, we've had technical business books, we've had leadership books, all of the above.
Well, I love to read, but I'm not a big fiction guy, and my favorite book is the Zen and the Art of Motorcycle Maintenance. I don't know if you've ever read this book, but it's it's a story about a guy and his son that they go on this motorcycle trip, and I think it was written in the 70s or somewhere in that time frame. But it's quite interesting to read even today, because the author is really trying to connect the challenges that the world is trying to overcome with the introduction of technology, right? And so it's very philosophical, and so he is specifically tying it to Eastern and Western thought. But I think it's a great read even today, right? Right. You see the same kind of challenges, right, associated with technology and how it's impacting people's lives, and seeing that somebody 50 years ago wrote about this topic, and it still applies today. I thought was quite intriguing. And I really enjoy the pace, because he jumps into these really deep technical discussions about this, and then he pulls back out and talks about his motorcycle trip with his son and how that's going, and so there's kind of this ebb and flow between the really technical stuff, and then kind of more of a maybe not necessarily a fun story, but a story, right, that engages you in that way.
Awesome. Perfect. Well, thank you so much for joining the show today. Really grateful for you for sharing your thoughts, your story, and your journey in the industry. So I look forward to seeing you at future events, and maybe one day down in Auburn.
Yeah, absolutely. Thanks for having me. And yeah, you're welcome here anytime. Just reach out, and anytime you're close to the Atlanta area, we're not too far. Happy to have you here and show you around and see some of the things we're doing.
Awesome.